Hi everyone, and welcome to our monthly What's New in Octave. This is the second episode of a series of live events for IoT developers around Octave, the edge-to-cloud data orchestration platform by Sierra Wireless. As always, this session is presented by members of Octave development team at Sierra Wireless. So I'm Thibaut Cantegrel, I'm in charge of the developer programs at Sierra Wireless, and today with me, it's a pleasure to introduce our main presenter for today, Nicolas Joyeux. Hi, Nicolas.
Hi, Thibaut. Hi, everyone.
Nicolas is embedded software development senior engineer in Octave team at Sierra Wireless. So thank you all for joining this first session of the year. Before starting today, I'd like, on behalf of the team, to wish you a very happy and successful new year 2021. All right, so if you are not familiar with Octave yet, we recommend you to check out our Octave tutorial videos on Sierra Wireless YouTube channel. As usual, this session is recorded and will be added to our YouTube channel in the coming days. All right, now let's see what's on the agenda for today. So as always, the session will focus on new or updated features recently deployed. And today, Nicolas will cover 5 new features. The new one, namely a universal serial parser, I'm sure you remember from our previous session. Augustin and Julien presented you this feature on the device side, on the edge side. You used it, you had the demo to use it with JSON. Today, it's a very new feature deployed yesterday, actually. So very recently. Today, yeah, actually today, yeah, exactly. We planned it yesterday and it has been deployed today, so brand new. It is the USP services feature in Octave UI. So very exciting, and Nicolas will show you how it works. Then Nicolas will present the Simplified Edge Action API, the nested observations, the startup indicator, and the timers on the edge side. So you'll see all that, and you see some code, you'll see it running, and so on. And as usual, we'll have a question and answer part at the end. So please use the chat during the session. You can start right now using the chat to ask your questions. We'll take them on the fly when we can. Otherwise, we'll keep them for this Q&A part at the end. All right, and with that, I think, Nicolas, the mic is yours.
Thank you, Thibaut. So this is a brand new feature, not feature, but this feature was already available in previous firmwares, but since today, the Octave user interface allows to set up your universal serial parser configuration through a new service, which is way more convenient than editing the JSON file. So this service is located under the services page. And as the other services, you can select on which UART you want the service to be run. So when you select the universal serial parser, the Windows is split into 2 areas. In the first one, you set the serial configuration. This is similar to Modbus or CanOpen. And then in the bottom area, here we have the settings of the serial parser. So you can here see the 3 strategies that are supported by the edge device. So in this session today, I won't go deep into the details, since Thibaut said Last time, Julien already spoke about USP in details. So here I just want you to show briefly how it works from the user interface point of view. And so how you can do the match between the JSON file and the user interface. So 3 strategies. The first one selected by default is the fixed length. It means we expect to some data to come into the device, and every here in this case the frame length is set to 60. Every 60 bytes the frame is cut and is pushed to the resource, to the USP resource. So here in the now in the user interface, you can easily select the frame length, and you can also select the timeout, which is written here below to indicate the maximum time to receive this data. There is also the delimiter strategy. Here you can set I think it's maximum 255 delimiters, which are an array of bytes. And as soon as one of those found into the incoming data, the serial parser decides that he has received a frame, and so once again cut the incoming data and push this frame up to the upper layers. So here it's more with the user interface, it's more convenient and easy to add delimiters, remove them, and modify them. We can also select sorry, before moving to ASCII mode, here in the format, we have now, this is what was called string mode in the JSON. This is ASCII mode. With this mode, in fact, the data is the same, but is displayed into ASCII charset. And when this format is selected, with this strategy, the delimiter is removed from the frame, so you can keep only the characters, the interesting characters. So for more convenience, you can also select ASCII here to display the byte into an ASCII value, an ASCII character. So this is an example of 2 delimiters. So every time the serial parser is looking for an OK or error string to decide of the frame. And finally, last strategy. Its name is dynamic length. It means it's useful when the protocol used between the device and the asset is based on a field present in the frame, which indicates how long the frame is. So here now the user interface allow to set the where is the frame, the size field, its length, and also if there are some extra bytes at the end to be removed, like typically CRC. So when moving here the length, we have this drawing that allow to better understand how it will read the length field into in the frame. And you can select big endian or not according to how is encoded the length in the length field. So I'm not sure I want to spend more time on it. If you have some questions about universal serial parser, please, you have online documentation, of course, but you also have the first session with also a demo. And yes?
Nicolas? Yeah, we have a question here from Ludovic, who's asking, is USP only to read from a serial port?
No.
Can be send write commands to the serial port?
No, USP can be used both to receive data from an asset or to transmit to the asset. Here, but in reception, when the device wants to transmit to an asset, the whole data is transmitted. So there is no particular configuration. That's why this interface, this user interface, focus on received data. So once your strategy is set up, here does not we can't see here, but there is the usual apply button that creates the resources, the USP resources that
so
allows to receive and to write data.
The thing we saw last time, right?
Yeah.
Okay, good. Thank you, Nicolas.
And hello, Ludovic.
So there is another question, I think. I take them on the fly, Nicolas, because it's related to what you were saying. So when you have a use case where you have to send a command and then wait for the answer, right?
Yes.
So how do you do that? Can you do that with this user interface, or do you have to do it like we saw last time directly in JSON?
Actually, when you create your universal serial parser configuration, maybe I can try to. You know what?
Maybe
I'm trying a live.
Okay, good.
Set up the service. Let's try.
Okay.
Hop. I'm trying just. I'm looking for a delimiter, which is 20, 21, 22. Okay, whatever. Save. And then, if everything goes well, in USP, here there are. So you can see the configuration has been set up according to the service. And here are two resources. One that can be used to write what is to transmit data over the serial link, and value, which is a resource which is filled with the frame, with the data according to the strategy. So if so, we have a question: if we send something, can you repeat again the question, please?
Yeah, the question was you have to send some data and wait for the I mean, you have to send a command and then wait for some time to get the answer, to get the feedback. But maybe what we can do, Nicolas, maybe as we have other features to show today, maybe we keep this one for the Q&A session at the end, and maybe we can dig in more details into this one. And maybe during this time, Ludovic, who asked all these questions, can maybe detail a little bit more what he's willing to do and so on. And by the way, for everyone, if you have some use cases where you think USP is a good feature or you would like to use it and so on. Feel free to comment as well. That's very interesting for us to know what are your use cases, how you want to use it and so on. And this session, this what's new in Octave is held by the R&D team because then with your feedback, it's really nice for us to have your feedback and then enhance our features thanks to your feedback. So that's really what we want to see. So don't be sorry, Ludovic, and if you can give us more details, we'll try to answer you at the end, or we'll take the question on the forum as well. So Nicolas, I give you back the mic for the next feature.
Okay. Next is we provide new functions to access resources and observations in edge action in JavaScript. So the goal was to make the API more friendly. We still support the current what I named the legacy API functions, but now they appeared as deprecated in the edge action editor. So here are, for instance, the new function to read resources and to read value. So there is resource.read, which allows to get a tuple, which is a value of the resource, the current value of the resource, and its timestamp of its last update. And we also introduced resource.readValue, which allows to get only the value in one useful function. So this is close to what existed before, but in my opinion, with function names more friendly. We also support observation statistics. Let's say statistics. So it was before supported by datahub.query. And so we provided those three functions: observation.getMin, getMax, getMin, to more easily provide the service. So the parameters are almost the same as before. We have to indicate an observation name and a value here, which is the time window where we want to get the samples. And if this parameter is optional, if we don't, if it's not provided, then we take the whole buffer. And finally, this is a new function. The idea is to provide, is to help developers to provide the whole buffer, so it can do some math on it or whatever he wants. If he wants to do some calculus, some calcul. So this function returns, compared to the previous ones, an array of tuple value and timestamps. That's it.
Okay.
No, I wanted to. Yeah. Sorry.
No, go ahead. Sorry.
Okay. I would like to show you nested observations. So what we call nested observation is that yes.
Excuse me, just a question arrived on the previous feature. So a quick question from Jan: can we clean the buffer after this call?
Can we clean? I don't think so. I don't know.
So that's fine.
No, Tommy, there is no.
We can talk about it on the forum. Maybe it's a good question for the forum then.
It's a good question. For now, observation are just it's just read only. We can't flush an observation. So, but it's a good point. It's a good point.
Okay. Cool. Thanks.
Okay. So nested observations. So for now, this feature is available on all firmwares because something has been upgraded in the system, in the backend, to allow it. And now you can, when there are some JSON value which has a child and children, you can set an observation on it. For instance, in util/cellular/signal/value/bars, not slash value, trigger, sorry, signal/bars. Then you will get into the stream. If we, for instance, this is the case of observation to the cloud, we can access directly to the child element. So this is new because it was not supported before. This is really useful also for Modbus registers, for instance. Just wait a little if there are some questions on it.
No, you can move to the next one. Thanks.
Okay. Here, this is a new feature which is introduced, which will be introduced in the incoming firmware 3.2.0. There is this resource in Cloud Interface application. Its name is Cloud Interface /config received /value. This resource already exists, but is not reliable because it's triggered only when the config is received but not executed. From 3.2.0 firmware, this resource will be triggered when device has received the configuration and also has executed it. It means when there is some virtual resource configuration, it means it will fire when all the virtual resources are created. If there are some timers, it will fire when all the timers are fully created. Same thing for from GPIO or ADC. And so this is a way to help developers to indicate that the system is ready to start. So typically, a user will add an observation on this resource and call an edge action to perform some init stuff, some logic he want to do at the very beginning of when the system starts.
So very useful. We can maybe recall everyone that the current, the last firmware available currently is the 3.1.0, right?
Yes.
And then the upcoming one very soon is this one, this 3.2.0. And by the way, before I get the question, because we had the question last time, the last firmware is now available for Mango Yellow as well. So if you have a Mango Yellow with WP 76 or 77, you can download the last firmware with Octave. It's from Octave or from mango.io or everywhere. Okay, thanks.
Okay. Now I would like to talk about timers. So this is a new features introduced in 3.1.0. So these features allow to create up to 50 timers with a single JSON configuration. So there is no service page available yet. So for now, you have to configure it manually via this JSON resource. So here is the syntax. You can, each line is a timer, and a timer is defined by different parameters and by a name. So here is the timer name, and then some parameters. And the first parameters I would like to show is the mandatory one, is the period, which is the timer duration in seconds. It can be a float, and it has to be strictly positive. A period of 0 has no meaning. And then repeat. It allows to set the number of times the timer will fire. A value of 0 means the timer to repeat indefinitely. A value of 1 causes the timer to run only once. And if this property is optional, so if it's not present in the configuration, like in my simple timer, then the default value is 1. That is to say, the timer fires only once. And finally, there is this parameter Autostart, which is quite explicit. By default, this is if this parameter is not present, the value is false. It means when it's to false that the timer needs to be manually started. If it's set to true, the timer will automatically start at system start. So once the configuration written and apply to /timer/config, then the resources are created. It's similar to the virtual resources. So here we can see my simple timer, my timer 1, my timer 2. So here are the 3 timers. For each of those timers, 3 resources. First one, command. So this is where we will control the timer. State is JSON, but allow to know if the timer is running or not. And then value is an integer value, which indicates, it's a counter in fact, which indicates the number of times the timer has expired. Okay. So control, how to control manual timers. So we have to push a string into those command resources. The 3 commands are supported: start, stop and restart. So starts the timer. If the timer is already running, it's useless. It moves the timer into the running state, and timer the value resource is set to 0 at start, and then if the timer is not running, and then it moves to 1 or 2 or 3 depending on the repeat parameter. If we stop the timer, so it stops the timer and it moves the timer to idle state. Restart, this can be used when the timer is running to force it to start from 0.
Okay.
And I can see an error here. It's not to idle state, but running state. So the state, as I said, so there are two information so we provide. If the timer is idle or running, this is in a JSON format. And so value, this is the counter value incremented every time the timer expires, and back to 0 every time we send the start or restart command. Okay, I hope I don't go too fast.
No, I think that's good. That's very good.
Okay.
I don't have any questions so far on this part.
Okay. So I did an exercise. For instance, we need to write a sensor value 5 times, spaced by 10 seconds, and do this measurement every hour. So one solution with a timer is to daisy chain 2 timers, create one timer T1 that fires every hours indefinitely, started automatically at the system start, create another timer T2 that fires 5 times with a period of 10 seconds, and then can be started manually. Create 2 ejections, action 1, which is called when timer T1 fires. This is the glue between the 2 timers. And also finally action 2, which will actually do the read of a sensor value. So which will be a map on T2. So the JSON implementation of this information is this: T1 period 3600. So it makes 1 error. Repeat 0, so repeat indefinitely, and auto start, so to start it at the beginning. And T2, so fires every 10 seconds and repeat 5 times. So now I can show you with the code in place on my device. So here is the configuration of what we saw, the 2 timers, T1 and T2. And I have started the demo. So you can see T1 is indefinitely running, as we saw here. It's already, so I have started it 31 hours ago. And T2 is not running. And the last time he ran, in fact, it fired 5 times. So I put some observations on the counter of those timers. And they are connected to 2 ejections, so action 1 and action 2. Action 1, so is simply a glue between the two timers. So when the timer 1 fires, we send the start command of timer 2. Okay. To start the measurement. And action 2, this action will actually do the sensor measurement. So it's just a simple extra code here. We have to skip when the counter has the 0 value, because we are just interested in value 1, 2, 3, 4, 5, not the 0. Else it will make 6 measurements. So every time T2 fires, we read, for instance, here an ADC input. And in this demo, I send the value directly to the cloud. And here, so we can check everything is going on correctly by selecting the stream and the default, because everything is sent into the default. And we can check here, for instance, those 5 measurements are done every 10 seconds as expected, and previous one was 1 hour ago. So it looks working as expected. So this is an example of timers. We hope we wanted to keep it simple and easy to use, but convenient, but to provide, to allow a lot of different configuration and a lot of services.
Yeah, very flexible. Yeah.
Yeah.
Thanks.
So I'm done with my the features I wanted to show you today. So now, Thibaut, if you have some extra questions.
Excellent. Thanks, Nicolas. If we go back to Ludovic use case, so Ludovic has provided some. So his use case is simply send a string as a command, wait a bit, and then read an answer as a string. Jan gave a bit of detail here. He said that he's using USP for 4 months now. It's working fine, read and write. But his feedback is that so the feedback is not linked to the write, right? So what you read after is not linked to what you write. So you have to process it in an edge action actually.
I'm not sure to fully understand, because read and write is not related. You can push any data to an asset. It can reply as soon as it receives some data, or it can reply never. Or so I think, but from what I understand, yes, an edge action is the more convenient way to deal with, or maybe combined with timers. We can do some tempo between writes typically.
Yeah. Oh yeah, exactly. So if you guys have any more questions, or if you don't know exactly what is the best way to do things, feel free to open a topic on the forum. You have the link here on this slide, forum.crls.com/c/octave, and the team here, so Nicolas and other folks, Augustin you saw last time and so on, they are answering on the forum, and other CR wireless colleagues as well. So feel free to ask questions on the forum, and we'll answer your question definitely there. All right. I don't see any more question. We have a thank you from Ludovic. You're welcome, Ludovic. Okay. No more question. If you have any question on the topics from today or any other topic from last time, feel free to ask now. All right, I don't see any more questions. All right, so right after this session, you will ask to answer a quick exit survey. So here as well, you can ask your question in the exit survey. Feel free to say what you thought about this session today, the format, and so on. Nicola, if you can jump to the next slide, please. And yes, and the next session is scheduled for February 11th. You can already register for it. The registration is already open. It's the same time as now. So thank you, everyone. Thank you, Nicola, for this session.
You're welcome. My pleasure.
And thank you, everyone. See you soon on the next session, maybe on the forum. And I look forward to read your comments from the exit survey. Thank you, everyone. Bye-bye.
Thank you.